Welcome. What I've taken the liberty of already drawing on the board is a piecewise function. Okay? Piecewise functions you may not have studied before, but all that's really going on here is you have some function that can't be defined only by one equation. Clearly it cannot, right? This is a function, it passes the vertical line test, but it's defined by two equations, and sometimes piecewise functions are defined by several equations, right? But in this case, we're following, this is the kind of setup, the kind of notation you would see for a piecewise function. So one function, f of x, is defined by this linear function, x plus 4, or 4 plus x, where x is less than or equal to 0. So we're following the linear function that would normally look like this forever, the diagonal line that goes through a y-intercept of 4. On forever, we're only following it for values of x that are less than or equal to 0. So starting with, or ending, I should say, with where x is 0 and y is 4, then we have a point like -1, 3, -2, 2, -3, 1, -4, 0, and then on forever. Let me extend this just to show you. This doesn't stop here, right? This goes forever. Extend this too. All right? So we have that part of the piece, that part of the function follows this piece, right? This sort of ray. And then we have, we're following a quadratic function, y equals x squared minus 4x plus 3, where x is greater than 0. So implying it's going on forever. I've drawn that parabola here. It's a parabola, right? It's quadratic. So it's going to follow that function, that equation, I should say, for this part, where x is greater than 0. We're going to stop the line. The line goes for x values from -infinity until 0, and then after 0, from that instant, so we have an open circle at the point 0, 3 in this case, so where x is 0 in this function, y is 3, and then on there, we follow that parabola forever. This is a piecewise function, something a little bit new. All right? That is one thing I wanted to introduce, and I reminded you guys how to graph a parabola here. I showed the line of symmetry equation to find the x value of the vertex, and then just by plugging in that number to the function, we get the y value. Right? When we plug in 2, we get -1 for y. So it's always a good idea to start with the vertex, and then to make a table. Keeping the vertex in the middle, you'll have symmetry in other spots because of the nature of quadratic functions. So quickly, just to remind you how to graph a parabola. But the key parts of this video are talking about transformations. We've talked about reflections, translations, shifts, right, left and right. And we've also talked about how to make a graph narrower or wider based on sort of the lead coefficient, right, multiplying a function by a certain value, right? But we haven't talked about what happens in terms of the transformation. What happens if you take the absolute value of the whole function, or if you take the absolute value of just the independent variable, just the x value. So specific transformations occur when we have this kind of a situation. So I want you guys to think about, all right, in terms of transformations, in terms of translations, reflections, whatever, what is going on when we do these two things, the green and the blue transformations? What's going on? So you should know what happens verbally. You should be able to explain what happens after this video, and also to see how to draw each of those two. Okay, you can just memorize some of these. There's a specific thing that happens for each of these. All right. So we're taking this piecewise function, which I've drawn very large on this board, and let's first do the green one. The absolute value of f of x. In other words, that's the absolute value of y, right? So if you think about absolute value, the absolute value of something is itself when it's positive, when that something is positive. When that something is negative, the absolute value of a negative is positive. So if we're taking the absolute value of y, where y is positive, we leave it. Where y is positive, anywhere above the x-axis. I'm like, rolling down the street here, just like listening to some hip-hop music, sorry. When the y value is positive, we stay the same. The values stay the same. Where the y value is negative, where you're underneath the x-axis, those y values become positive. Okay, so long story short, for any point below the x-axis, they get reflected over the x-axis. Okay, for any point below the x-axis, those points get reflected over the x-axis. All right, because we're taking the absolute value of essentially y, so all the y values become positive. All right, so when we're drawing this, we keep all of the values where y was positive the same. So I'm going to kind of draw this right on top of the red. It really should be right with it, right? So it's the exact same graph where y is positive. And then we have, again, open circle here, and we follow this and this part too. Okay, so the green, if we're drawing the absolute value of f, those values, these red values that are above the x-axis remain there. Okay, but what changes is, okay, these guys all get reflected over the x-axis. So this piece, we keep the same sort of slope, right? This slope is really positive 1. It becomes negative 1, but the same steepness for sure. And we can just draw it like that, right? So these guys, this red piece here and this green piece here are mirror images over the line, over the x-axis. All right, so any y value that was negative, those points, just reflect them over the x-axis. This point here, which was -5, -1, if you're being picky, will become -5, +1, so on and so forth. Now, the other part that's below the x-axis is the sort of the low-ish part of this parabola. So that's going to be tough to do to be exact, but take the vertex, which is under the x-axis, and reflect that over. So we're right about here. Now at the point 2, 1 instead of 2, -1, and that should be enough. Just kind of drawing the smooth, curvy part. Okay? So the way our function would look, just a quick little sketch would be something like, all right, the absolute value of x, if you're asked to graph it, it would look like this. It would be, sort of have that part to it, and then you'd be going up here to a certain point, and we still have that open circle that was the same, and then coming down here, but then at this point, up, and then like that, on forever. Okay, that's how it would look if you were just doing this on a blank grid. Right? This little graph right here should be about what your graph should look like. Okay, that is the absolute value of f of x. And this will always be the case. Keep in mind, you can even memorize this like I said. If it's the absolute value of the whole function, everything above the x-axis will stay the same. Redraw it. Redraw every point above the x-axis exactly how f originally looked. But any point that was below the x-axis, that gets flipped over the x-axis. All right? Now, f of the absolute value of x is a little bit trickier. It's a lot trickier to understand. But again, this is one of those ones you kind of just want to memorize if you're struggling with the understanding. You're taking the absolute value of the x value, okay, and then evaluating the function. So you're only evaluating the function with positive values. You're only evaluating the function with positive values. So really, whether you plug in, say, -2 or +2, you're taking its absolute value, so you're getting 2, and then you're evaluating the function. Okay? So whether you use -2 or +2, you're going to get the same answer, because what you're really going to be plugging in is 2, because you're taking its absolute value before you're plugging it in. So in other words, long story short, whether you plug in a positive or a negative number for x, you're going to get the same value for y. And that's going to happen where x is the positive one. All right? So what happens in this case, in the blue case, is something that looks very different from the rest. All right? Let me kind of erase the green for now, so you're not confused. Some dead air right here. I know, I'm sorry. How are you? I hope things are well. I hope you're having a good evening. I'm not feeling too great, but God, it's a beautiful day. I got to get outside. Okay, so green function is gone. We have it saved over here anyway. The f of the absolute value of x. Ooh, lights are going out. Ugh. Well, okay. We take every point to the right of the y-axis, and don't touch it. It is there. All right? That's not going to change. We're still evaluating at all those points. Whatever x was, the absolute value of 3 is going to stay 3. So we're evaluating the function. Any point here is not going to change. All right? That's one thing we know. But any point to the left of the y-axis is gone. Forget about it. It's not there anymore. Every point to the left of the y-axis is garbage. Okay, forget it. What we do with that left-hand side of the y-axis is totally based on the right-hand side of the y-axis. Because whether, again, we use 2 or negative 2, we're going to take the absolute value of it, so we're going to get 2. So whatever the positive version follows, the negative version has got to follow also. 2, negative 1, well, negative 2, negative 1. 1, 0, well, negative 1, 0. 3, 0, well, negative 3, 0. And so on and so forth. Now, 0, 3 is a tricky one, okay? But this, ooh, I didn't actually consider this. This is kind of a funny thing that happens, right? But because that point is not really there, 0, 3, let's see. Where x is exactly 0, I guess we still, the absolute value of 0 is 0. Yeah, so I guess we would have to follow still this function. Because x equals 0 with this one, we still would leave that point up there. We're still following this function where x is exactly 0. So the point on the y-axis is not going to change. That's fine. These points are all gone, though. Anyway, that was kind of interesting. I hadn't thought that would happen. But that took me a second to think about. Also, 4, 3. So we have negative 4, 3. 3, I guess it would be up here. There. Okay? So let me erase these. All right? So the graph is like this. We're just going to draw this down here, and then up like this, and on forever. So this is now gone. You've seen this for a while. You don't need to keep seeing this. If we're asked to sketch, so instead of drawing this separately, like I drew this one, this, and I'll even complete the blue, this should be part of it too. So I'll even erase the red. A lot of dead air in this video. I'm sorry, guys. But I'm trying to be perfect, and again, I'm not feeling great, so I'm kind of out of it. But, okay, and then 4, 3. It's like this. All right. So this is the way the graph, that is an open circle, the graph would look. It is a perfect reflection over the y-axis. That was the point 0, 4 from before. And with the exception of that one point. I didn't draw it great, but one key takeaway from this, guys, it's a little bit of a tough concept to understand, but whenever you have to do not the absolute value of f, but f of the absolute value of x, you're going to end up with perfect symmetry over the y-axis, okay? You just take, again, every point to the right of the y-axis stays how it is. Every point to the left of the y-axis disappears. Ignore it, no matter how it looks, okay? And you just redraw the right-hand side on the left. Sometimes it will be the same as the original function. If there was originally symmetry about the y-axis, yeah, you'll have the same thing. But just keep in mind, what will always be the case, if you've done this correctly, is the left-hand side of the y-axis will be a total mirror image of the right-hand side. So you start with the right-hand side, make sure you know what that looks like, and then you draw the left just as a reflection. So it's kind of an easy thing to do. All you're doing is reflecting the right over the left. All right? So that's the f of the absolute value of x, whereas the absolute value of f of x, you just worry about any point underneath the x-axis, you flip that over. Okay? It's just a little intro, or not an intro, 2 additional transformation problems. These are both reflections, right? Types of reflections. Right? Wasn't my best video, but you get the idea. Bye.